In this video we're going to discuss a couple of theorems. One is called the remainder theorem. The remainder theorem says if we have a polynomial and we divide by some factor x minus c, okay, whatever that happens to be, the remainder that we have when we do that division, which we're going to use synthetic division for, the remainder that we have is what you would get if you actually just plugged that number in to the polynomial. So I'm going to go ahead and do this both ways, and I'm going to explain how this is going to help us out a little bit. So we want to take this polynomial and we want to divide by x plus 2. So if I do synthetic division, if I'm dividing by x plus 2, I'm going to put negative 2 in the box. I'm going to do my coefficients across the top. That's 3, 5, negative 4. I don't have an x squared term, so I need to make sure to put a 0 there. 7, and 3. And I'm going to go ahead and do this synthetic division. So I'm dividing by x plus 2, so I put negative 2 in the box. And I write my coefficients across the top. Don't forget about those missing terms, so you have placeholders there. And we're going to go ahead and do this synthetic division. So we drop the 3. 3 times negative 2, add. Negative 1 times negative 2 is 2, add. Negative 2 times negative 2 is 4, then add. 4 times negative 2 is negative 8, and then add. And then negative 2 times negative 1 is 2, and we add, and we get 5. Now remember, the remainder is that last number that we have. So that's our remainder. Look, using the remainder theorem, it doesn't really matter what I have left down here other than the remainder. So what this is saying is, the second part says find p of negative 2. Well, p of negative 2 would say take negative 2 and plug it in to the function, right? So it would be 3 times negative 2 to the 5th plus 5 times negative 2 to the 4th minus 4 times negative 2 to the 3rd plus 7 times negative 2 plus 3. Now, if you had a calculator in front of you, this would not be that hard to do. You just plug all this into a calculator. If you did not, it's going to take you a little bit of work to do this. I have to do negative 2 to the 5th and then multiply by 3, negative 2 to the 4th, multiply by 5, add those things together, and so on. It's going to take me a little bit of time to work through this. So the remainder theorem says that instead of plugging in negative 2 into the function, I can do synthetic division with negative 2, and my remainder is what I would get. My remainder is what I would get if I plugged that number into the function. So synthetic division, in my opinion, is much easier than working this out by hand. So if I know I want to find p of negative 2, I can just do synthetic division with negative 2 really quickly, get my remainder, and that is what my answer would be. The next one is the factor theorem, and it says that c is a 0 of p if and only if x minus c is a factor of p. So here we have a polynomial, x cubed minus 7x plus 6. Show that p of 1 equals 0 and use this factor to factor p of x completely. Show that p of 1 equals 0. So I'm going to use the remainder theorem to do this. What I'm going to do is I'm going to do synthetic division with 1. And that means that I should get a remainder of 0. So my coefficients are 1, 0, negative 7, and 6. Again, I need to put a 0 for my x squared spot. Drop the 1, multiply and add, multiply and add, multiply and add, and I got a remainder of 0. So I have shown that p of 1 equals 0 because the remainder I got when I did synthetic division with 1 was 0. And it says to use this fact to factor this completely. So what that means, I'll do this out to the side. What that means is that I did have x cubed minus 7x plus 6. And then I divided by, or I did synthetic division with 1, which means that a factor of this, think about this, is x minus 1. If I did synthetic division with 1, that means I divided that thing by x minus 1, right? When we do synthetic division, we take the opposite of this number, and that's what goes in the box here. So what I'm saying is, because I got a remainder of 0, I know that x minus 1 is a factor of this polynomial. So I can rewrite this as x minus 1 times what I have left. Well, I did have x to the third, which means when I do synthetic division, this is now x squared. So now I have x squared plus x minus 6. That's what I got from this. This would be the x term, and then I would have negative 6 there. And if I want to then factor this completely, because I know that x minus 1 is a factor, I've got that. And the other one, what I have left, now factors really nicely. This would be x plus 3 and x minus 2. And we've taken our polynomial and factored it completely. Because we were able to show with synthetic division of 1 that we got a remainder of 0, that tells us that x minus 1 is a factor. If you tried to factor this thing, x cubed minus 7x plus 6, you would have some trouble there, probably a little bit of trouble there, because you don't know how to factor a cubic trinomial. You know how to factor a quadratic trinomial, which is what we did here, but not a cubic trinomial. So synthetic division will help you to break down polynomials, to get those into factored forms, and create things that are much easier to factor. And we have our final factored form of that polynomial.